Trigonometry, Unit 6, Vocabulary Part 1. Thank you for tuning in to my next video. Hope you enjoy this and hope you learn a lot of different skills and concepts involving the skills and vocabulary terms mentioned in this video. First, we have circular functions. Circular functions are defined as the 6 basic trigonometric functions defined using a unit circle. It says, note, remember the 6 basic trig functions are sine, cosine, tangent, secant, cosecant, and cotangent. Definition of sine and cosine says if the terminal side of an angle theta in standard position intersects the unit circle at point P, x, y, then cosine of theta equals x and sine of theta equals y. So some terminology here that you might not remember unless you watched the previous video or have been taught this is, first of all, terminal side. What does that mean? Terminal side is the part of the angle that is basically where the angle starts. For example, in this case, the terminal side starts here along the x-axis. That is an angle in standard position. The terminal side will always start at the x-axis, and the other side of the angle will always be someplace around the unit circle, someplace else. That's called an angle in standard position. That's what standard position means. And then the cosine of theta represents the x, and the sine of theta represents the y coordinate. Notice here on this graph, cosine of theta goes along the x-axis, goes to the right, and sine of theta represents the y coordinate because sine of theta goes up and down. And if we look at the ordered pair right here, it is the ordered pair or the point cosine theta because that represents the x coordinate, comma sine theta because that represents the y coordinate. Graphing sine and cosine functions. To graph y equals sine theta or y equals cosine theta, use the values of theta expressed either in degrees or radians. Ordered pairs for points on these graphs are of the form theta, comma sine theta and theta, comma cosine theta. So remember that these values can always be expressed in either degrees or radians. So look here at this first graph here at the top. These are all have measurements of degrees. Okay, this represents the measures of the angles in terms of degrees. This angle, or this graph here where it says cosine of x, see along the x-axis, those are measurements of angles in terms of radians. I know they're in radians because of the pi symbols in each of those expressions. So this is a graph in terms of radians. This last graph here on the lower right section of this slide shows the measurements in terms of degrees and radians. In case you're not familiar with the unit circle or you forgot the conversions between the radians and degrees from the unit circle, those are all there for you right there, the important ones, most important ones. This first graph here at the top represents the sine graph. I can tell it's a sine graph because the graph starts here, it has a point here at the origin, and it curves the way it does here. It keeps curving like this. That represents the sine curve or a sine graph. So one's a cosine graph. I can tell for one thing because it's labeled there, but also I can tell because if you look at the origin, there's a point above the origin. That's where the cosine graph is basically going to start. If you start from 0, look right above the origin, and there's the cosine graph. And it curves this way to the right, and it curves the other direction to the left. So that's how I know it's a cosine graph because of where the point is on the graph here, right above the origin. Whereas a sine, the point is right at the origin. The graph over here to the right is a tangent function graph, and I can tell because I can tell by looking at it, that's what a tangent graph looks like. Now these blue dashed lines here, those represent the boundary lines, sometimes referred to as asymptotes. They're boundary lines that the graph will never cross. So that's representing the tangent function. That's what a tangent function graph looks like. So again, your ordered pairs are theta, which represents either degrees or radians, whether you're doing with degrees like the sine graph or radians like the cosine graph, or you have degrees and radians combined like the tangent graph. And then the other measurement, sine of theta, represents what your answer would be based on in terms of degrees. And cosine theta represents your answer in terms of, in this case, whatever you get for cosine involving those radian measurements. Next, we have here, this is a secant function graph, and this next one is a cosecant function graph, and then this one here is a cotangent function graph. I can tell the difference between a secant and cosecant. They both have the U-shapes. Notice U-shapes here, but the difference between a cosecant and secant is The secant will have the minimum point of the U-shape right above the origin, and the cosecant does not have any points above or below the origin at all. That's how I can tell it's a cosecant. They're both U-shapes, but that's the difference. Secant has a point above the origin, and cosecant has no points above the origin or below the origin. This is a cotangent graph because I can tell the lines are curving differently. Again, notice the asymptotes or the boundary lines in each of these cases. The secant graph has a boundary line at negative pi over 2, another one at pi over 2, another one at 3 pi over 2, and I forgot to mention this first one at the boundary line at negative 3 pi over 2. The cosecant graph has boundary lines at negative 2 pi, negative pi, the y-axis itself, and pi also, and also 2 pi. Those are the boundaries for the cosecant graph. And the cotangent graph has boundaries at negative 360, negative 180, 0, 180, and 360. Those are the boundaries for the cotangent graph. Next, we have principal values. Principal values are defined as the values in the restricted domains of the sine, cosine, and tangent functions. It says, note, the domains of the trigonometric functions must be restricted so that the inverses are functions. The values are restricted to 2 adjacent quadrants. Now, if you guys don't remember the word adjacent from geometry, adjacent means next to. So they're restricted to the 2 quadrants that are next to each other. All right, 2 quadrants that are next to each other. So if you have an equation, y equals sine of x, okay, that can be graphed if and only if y equals sine of x, and here's the boundary, negative 90 degrees is less than or equal to x, which is less than or equal to 90 degrees, which means that your values have to be between negative 90 and 90. Now, where's negative 90 and 90 on the unit circle? Here you have a unit circle, negative 90 is down here at the bottom, and positive 90 is up here at the top. So the sine function, inverse function, is going to be restricted to the quadrant 4 and quadrant 1. Now, I don't know if you guys remember the quadrants or not. Let me explain that just in case you haven't been taught or forgot it. Quadrant 1 starts in the upper right corner right here, quadrant 1. And then the quadrants go in a counterclockwise direction. So there's quadrant 1, upper right corner. Here's quadrant 2, upper left corner. Quadrant 3, lower left corner. And quadrant 4, lower right corner. That's how the quadrants go in that order, counterclockwise. So negative 90 to positive 90, it's going to be these quadrants right here, negative 90 to positive 90. That's quadrant 4 and quadrant 1. That's where the sine function will be restricted to, the inverse sine function. The cosine function, y equals cosine of x, if and only if y equals cosine of x, and x is between 0 and 180. So all your measurements will be between 0 and 180. So where's 0 and 180 at on the unit circle? Well, 0 is here to the far right, and 180 is over here to the far left. So all the measurements between 0 and 180 means all these angle measurements right here in quadrant 1 and quadrant 2. So cosine restricted to the measurements for quadrant 1 and quadrant 2 for the cosine inverse. Well, inverse tangent. Tangent, y equals tangent of x, if and only if y equals tangent of x, and your values are between negative 90 and positive 90. So same as the sine values, going to be between negative 90 and positive 90 again, which means quadrant 4 and quadrant 1. All these angle measurements right here are where the inverse tangent function is going to be restricted to. Next, arc cosine function. Our cosine function is defined as the inverse of the cosine function. It is defined by the equation y equals cosine negative 1 of x, or y equals arc cosine of x. You have to make sure you understand the symbols right here, the terminology. They both mean the same thing. They both mean the inverse of the cosine function. So they both look different, but they both represent the same thing, inverse of cosine function. Arc sine function is defined as the inverse of the sine function. It is defined by the equation y equals sine to negative 1 of x, or y equals arc sine of x. And by the same token, arc tangent function represents or is defined as the inverse of the tangent function. It is defined by the equation y equals tangent negative 1 of x, or y equals arc tan of x. So make sure you understand these symbolisms, because on problems, on a test, or in assignments or whatever, or in the textbook, they can be one or the other. They will not be both. It'll be one or the other, and so you have to make sure you understand the symbols and what they mean. They all mean the inverse of these particular trig functions. So watch for them. Next, these are what the graphs would look like for inverse trig graphs. This is the inverse sine graph. Look what it looks like. This is the inverse cosine graph, and this is the inverse of tangent graph. Now, I did not say inverse functions because these are not functions. They're just the graphs of those inverse trig ratios. Okay, inverse trig graphs. They're not functions. Now, I don't know if you remember from Algebra 1, in geometry, they don't talk about it much in geometry, but Algebra 2 you should review it. And even in trig class, before this video, I had a video on functions. So a function is defined as a vertical line test, which means if you look at a function, or look at a graph, I should say, take any vertical line test in the graph and check it. Now, a vertical line should not go through more than one point. If a vertical line goes through more than one point, it is not a function. So a good vertical line to look at would be the y-axis right here. It's a very good visual to look at, to check to see if it's a function or not. You can definitely see it really well. So this y-axis here, the vertical line, goes through 3 points on this graph. That means that this picture, the way it is, this graph, the way it is not a function. The vertical line, the y-axis, goes to a point right below the -3. It goes to the point at the origin and goes to the point above the +3. So because it goes through 3 points in this vertical line, it is not a function. Cosine graph, same thing. You can definitely see at least 2 of the points that this vertical line, the y-axis, goes to. Goes to a point somewhere between -1 and -2, and goes to a point somewhere between +1 and +2. So because it goes through more than one point, because the vertical line goes through more than one point, this graph is not a function. Arctangent graph, same thing. Look at the vertical line, the y-axis. It goes through 3 points. 1 point below the -3, 1 point at the origin, and 1 point above the +3. So again, this graph here is not a function. So that's why we have restrictions. So remember the restrictions from the previous slide? That's why there are restrictions, because we want to try to graph the inverse functions of these trig ratios. And in order to do that, in order to make them be functions, we have to have restrictions to make that happen. So this slide shows the main 3 inverse trig functions. The sine, cosine, and tangent. Inverse of sine, inverse of cosine, inverse of tangent. So arcsine is the inverse of the sine. Notice the restrictions here. Notice the boundary lines, -π/2 and +π/2. Now, I don't remember from the unit circle or not, but -π/2 is equivalent to -90. And +π/2 is equivalent to +90. So once again, if you remember from the previous slide, the restricted values are from -90 to +90 for the sine, and this is why. Look at this graph right here. So it's restricted between -90 degrees and +90 degrees. About the inverse cosine graph, inverse cosine function graph. It is restricted between 0, the x-axis, and +90. Pi is equivalent to +90. So the arc cosine is restricted between the boundaries of 0 and +90. How about the inverse tangent or arctangent of x graph? Inverse tangent graph, function graph, is what it looks like here. It's restricted between -90 and +90, just like with the sine graph, inverse sine graph, inverse tangent graph is restricted to the same numbers. Again, here's your boundary lines. The graph does not cross those lines right there. Now, these are all functions because, based on the vertical line test, any vertical line will not go through more than one point. That's why these are all functions. But again, in order to make that happen, we had to have restrictions so that we can see a small section or a snippet of the inverse graphs so that we have inverse function graphs. Here are the other 3, the inverse secant, inverse cosecant, and inverse cotangent, or in other words, arcsecant, arccosecant, and arccotangent graphs. So here's what the inverse of the other 3 graphs will look like. Again, notice the boundaries here. Inverse of secant has a boundary at the x-axis and has a boundary at 180. Pi is equivalent to 180. So those are where the graphs are not going to continue because they're of the restricted areas, restricted values. There's also a boundary here at 90 degrees or pi/2. The graphs are not going to cross that line right there because of, again, what I showed you before in a previous slide, somewhat similar to that there's other boundaries. So if this graph were allowed to continue, it would look like a C here on the right and look like a backward C here on the left. Here's the arc cosecant graph. You can look at the boundaries here. It is bounded by positive 90 and negative 90. The boundary lines for that. Also has another boundary line here at the x-axis. The graph will not cross this line because of what I showed you before, somewhat on the cosine graph, or the cosecant graph, what the cosecant graph looks like. Okay, I meant to say cosecant graph. Here is the inverse cotangent graph. It is bounded by the x-axis, or 0, and 180. That's the inverse cotangent graph. Thank you for watching this video. Hope you enjoyed it. Hope you learned a lot of the vocabulary, terminology, and symbols to watch out for. And I look forward to you coming back and seeing my next video presentation on more trig concepts and skills.